How to master blue-green deployment for ML models. In this video, we will learn the step-by-step process of implementing blue-green deployment for machine learning models, enhancing your skills in managing deployments and minimizing downtime. Welcome to our video on mastering blue-green deployment for ML models. Did you know that with blue-green deployment, you can reduce downtime by up to 90% during model updates? This technique is a game changer for deploying machine learning models in production environments. In today's video, we're going to explore what blue-green deployment is, why it's crucial for machine learning, and how it can help you achieve seamless updates and minimize risks. We'll also walk through setting up your environments, switching traffic, monitoring post-deployment, and much more. Let's dive in. In this section, we'll delve into the specific benefits of blue-green deployment for ML models. One of the main advantages is continuous delivery. By maintaining two separate environments, you can seamlessly transition between versions, ensuring that updates don't disrupt users. This approach also significantly reduces risks associated with updates, as you can quickly switch back if the new model version has issues. Blue-green deployment allows for instant rollbacks, providing you with a safety net for unexpected problems. Additionally, it offers improved testing environments, where new versions can be thoroughly evaluated in a live setting before full deployment, enhancing user experience by ensuring stable and reliable updates. Now that we understand the benefits, let's discuss setting up the blue and green environments. The key is creating two identical environments that can run in parallel. Start by ensuring your infrastructure is capable of supporting both environments simultaneously. This might involve setting up additional servers or using cloud services to manage resources efficiently. Configuration management is crucial here. You need to ensure that both environments are configured identically to avoid inconsistencies. Synchronizing data between the environments is another critical step. This ensures that both environments reflect the same information and state, whether it's user data or model parameters. Lastly, maintaining environment isolation is essential, as this prevents changes in one environment from affecting the other, allowing for safe testing and deployment.
Let's move on to switching traffic between the blue and green environments. Traffic routing is a critical component of blue-green deployment. Load balancing techniques can be employed to manage the traffic, ensuring that user requests are directed to the correct environment. Before making the switch, it's essential to test the process in a controlled manner. Gradual switching allows you to route a small percentage of traffic to the new environment, monitoring its behavior before a full switch. This method minimizes risks and ensures any issues are caught early. Alternatively, an instant switch can be made if confidence in the new deployment is high. The key is to ensure that users experience a seamless transition without noticing any changes or disruptions.
After deploying your model, monitoring and testing are crucial to ensure everything is functioning as expected. Monitoring allows you to track key metrics, such as latency, error rates, and user engagement, providing insights into the deployment's performance. Automated testing tools can be employed to continuously evaluate the system, running tests to detect potential issues early. Implementing real-time error alerts can help you respond promptly to any problems, ensuring a rapid resolution. Post-deployment, it's vital to gather feedback and make necessary adjustments. This iterative process helps refine the deployment, enhancing the model's performance and user satisfaction over time. Rollbacks are an integral part of blue-green deployment, providing a safety mechanism in case of issues. Knowing when to initiate a rollback is crucial. Common triggers include performance degradation, increased error rates, or negative user feedback. There are several rollback strategies, such as full rollbacks, where all traffic is redirected to the previous version, or partial rollbacks, which target specific components. Rolling back ML models presents unique challenges, particularly regarding data integrity. It's essential to ensure that reverting to a previous state doesn't corrupt data or disrupt operations. Utilizing rollback tools and scripts can streamline this process, providing an automated and reliable method for reverting changes when necessary.
Automation is a key component of successful blue-green deployment. Popular tools like Jenkins, Kubernetes, and Circle-C can streamline the deployment process, reducing the risk of human error. Scripting best practices, such as version control and modular scripting, ensure that automation scripts are maintainable and scalable. Integrating continuous integration/continuous deployment (C/CD) pipelines can further enhance automation, allowing for seamless updates and deployments. Automating environment setup ensures that new environments can be quickly and reliably created, minimizing manual intervention. The benefits of automation include increased efficiency, reduced errors, and faster deployment cycles, all of which contribute to a more robust and reliable deployment process. To illustrate the power of blue-green deployment, let's explore a real-world case study. A leading tech company recently implemented this strategy for its ML models, facing challenges such as resource allocation and ensuring data consistency across environments. By leveraging automation tools and adopting a gradual traffic switching approach, they successfully overcame these hurdles. The impact on their business operations was significant, with improved deployment speed and reduced downtime, leading to enhanced user satisfaction. The lessons learned from this deployment included the importance of thorough testing and the benefits of having a robust monitoring system in place. Looking ahead, the company plans to refine its deployment strategy further, incorporating more advanced automation techniques to streamline future updates.
As we wrap up, let's quickly summarize what we've learned about blue-green deployment for ML models. This technique is crucial for minimizing downtime and ensuring seamless updates, providing a robust framework for managing deployments effectively. If you're ready to enhance your deployment strategy, start by setting up identical blue and green environments, utilize automation tools, and implement a solid rollback plan. We encourage you to engage with us by sharing your thoughts and experiences in the comments below. Don't forget to subscribe to our channel for more insightful content on machine learning and deployment strategies. Thank you for watching.